Okay, so today we'll solve GET 2019 question. This is a question from real analysis. This is question number 43. It is saying that let 1 less than equals to P strictly less than Q strictly less than infinity. And two statements are given. Little LP is subset of little LQ. While little LP is the sequence space such that Pth summable, it's Pth summable. And the second one is the capital LP over 01 is subset of capital LQ 01. Where capital LP spaces are the Lebesgue spaces such that Pth integral is finite. So these two are, we have means two statements are given. You have to, four options are given. You have to check which one is correct. Okay. So this is the NPTEL reference. This you can check. Okay, so let's start solving this one. So 1 less than equals to P strictly less than Q strictly less than infinity. So 1, so we will show this. The first one is correct. We will show LP is subset of LQ. What is LP? Let me write. LP is the sequence space. So either summation n equals to 1 to infinity mod xn to the power p, this should be finite. And for any x in LP, what is the norm? Norm x small LP is defined to be n equals to 1 to infinity xn to the power p to the power 1 by p. So in order to solve this one, that LP is subset of LQ, it is enough to show that LQ norm of x is less than LP norm of x. Right? Why? Because if x is in LP, as if x belongs to LP, which implies this norm will be finite, which implies by this inequality, if this is finite, then this will be finite. So means x is in LQ. Which implies x is in LQ. So this implies, we have started with the LP element, we have shown that this is in LQ, means LP is a subset of LQ. So it is enough to show this one. Now observe on that this one is scaling invariant. So if you suppose multiply some numbers lambda, then it is cancelled from both sides. So due to this scale invariance, we can assume that LP norm of x is again means norm 1. Right? So dividing both sides by norm xp, we can assume norm xLP to be 1 and enough to show norm xLQ is less than 1. So this is so So here we can assume that for x which is norm 1, for that norm x, LQ norm of x is less than equals to 1. So now as norm x LP is 1, which means n equals to 1 to infinity xn to the power p is 1. So if summation of all the terms to the power pth power is 1, which implies xn is less than equals to 1 for all n, because these are all mod are all positive numbers. So if total sum is 1, then each terms will be less than equals to 1. Now as each term is less than 1, now as p is less than q, is strictly less than q, so q is bigger, so if you take the qth power, because this is less than 1, so this will be less, right? Now take the summation over all n equals to 1 to infinity xn to the power q, so this will be less than, right? And so what is this? So this is the basically LQ norm to the power q, this is xn x to the LP norm of to the power p, and we know this is 1, so what we have got, LQ norm of x is less than 1. So this we have to prove, right? So you have got this one, so therefore means little LP is subset of little LQ for 1 less than p, strictly less than q, strictly less than infinity, right? So first one we have shown. Now for capital LP, so we have to show that capital LP, but this we have shown the second one is not correct. For 1 less than p less than q less than infinity, capital LP of 0 1, this does not subset of LQ01. What is LP spaces? So this is all functions which are measurable, Lebesgue measurable, such that integral 01 mod fx to the power p dx, this is finite and f is Lebesgue measurable. So we'll show that LP does not contain in LQ. So you will give a counter example. So these are Lebesgue measurable functions. So let's take fx to be 1 by x to the power 1 by q for x in 0 1 and 0 for x belongs to 0. This may not need to define, because Lebesgue measurable functions are defined almost everywhere. So like this, I am only writing this because this is defined almost everywhere sense. So now let's calculate what will be the pth norm. 0 to 1 fx to the power p dx. So 0 to 1 this will be dx by x to the power p by q, and we know p is strictly less than q. So what will be this integral? 0 to 1 x to the power minus p by q dx. So this will be x to the power minus p by q plus 1 by 1 minus p by q. This is from 0 to 1. So if you put, you will get 1 by 1 minus p by q. And as p is less than q, so this is finite as p less than q. So as the pth integral is finite, which implies f is in LP 0 1. So this is in LP. Now let's check, is this in LQ or not? 0 to 1 mod fx to the power q dx. So this is 0 to 1, fx is 1 x to the power 1 by q, so this is a dx by x. So integral is 1 by x, integral is log. But this is not convergent, this is infinite. So this is not finite. So f does not belongs to LQ. So we have find out an example which is in LP but not in LQ. So then therefore this cannot be true, because this function is in LP but this is not in LQ for p strictly less than q. So therefore for 1 less than p strictly less than q less than infinity, LP 0 1, this is not subset of LQ 0. Means this you can show that for 1 less than p less than, this is the other way around. 1 has LP 0 1, one can show, or LP AB over some compact is this. So therefore this one is not true. So what we have got, therefore, so 1 is correct, 2 is incorrect. So which one is correct? B only. 1 only is true. Okay.